All right, so let's start with a little bit of review. Make sure that you're checking the topics list that I included on D2L with all of your pre-labs and labs where you get those. Each section is, there's more detail about what's sort of expected for you to know after each of these topics. So what you'll notice is that starting on this topic and then all of the last four here, the expectation is not only that you understand these types of topics and how you would program them and the algorithms that they come with, but that you also conceptually understand these topics. So, for example, you should conceptually understand what a derivative is, what an integral is, so that you can apply it, or so that you can use these numerical methods that we're learning on simple problems by hand. So if I give you a set of data and I ask you what's the derivative at data point 4 using the forward difference formula, you should be able to do that as well as just be able to program it. So here I just am showing you the difference between both the differentiation and integration. That's numerical. So remember, if you have data, so here I have some 7 x points in their associated function value, which is plotted on the y-axis. So a derivative, remember, if you are going to use a forward difference formula that I have here, is going to be approximating the slope using the next point, or the point to the right, at every individual point. And so I've graphically shown that derivative and what it would be for this set of data in green and labeled it in green. And so when you take a derivative, you're going to have a derivative for every point. If you're doing a forward difference, you won't be able to define the derivative on the last point, and you'll have to use a backward derivative there. On the other hand, numerical integration is going to be the area under the curve. And so here I'm showing, in the graph, I'm showing trapezoidal rule, where you're connecting the two function value points with a straight line, which makes a trapezoid, and then the area under it is calculated by multiplying that average function value by the width of that trapezoid. And so for this one, to approximate the integral, you have to sum all of the little integrals. And I don't have a specific integration form written here. This is just general numerical integration. I've just drawn trapezoidal rule. So you should be able to recognize also all of the integration and differentiation formulas that we've discussed or used in pre-labs or labs. You guys have any questions about this? Okay. So one of the things that's happened a lot and will continue happening in the future labs is the use of functions, both by writing your own and by using the intrinsic functions. And I still get a lot of people coming to me and asking or saying, well, I don't know how to use that intrinsic function. So the expectation in this class is that that is what you're learning how to do, is figure out how to use any intrinsic function. So I will sometimes tell you specifically which one to use, and sometimes I won't. And so depending on the question, it's up to you to figure out both what the intrinsic function is and how to use it. So you need to go to the help and look it up and look at the inputs. So for example, in the last lab, that was trap Z. So in the pre-lab you had to use it, and then it was very helpful to use it in your lab. So the expectation is that you are both to be able to figure out what is the intrinsic function for the trapezoidal rule and how do I use it. And so I noticed that the most common problem with that function is people reverse the inputs. It has to go x first, then y. And if you do y then x, then you're going to get a negative of your integral because you're kind of like turning the function. So make sure that you're practicing and learning how to do that, because that is one of the outcomes of the class. As for writing a function, here I have a little function that I've written here where it has 2 inputs, 2 outputs. I'm not going into what this function does. And then to call that function from anywhere, whether it's the command window or another function, you have to provide it to inputs, and if you want to use the outputs, you have to provide those outputs where to go. So remember that these don't need to be saved as the same variables, or you can even input like actual values in, and these don't have to be the same variables. You can use whatever you want, and typically you're going to use something different.